This time I want to revolve this guy around the line x equals 3, so I'm going to draw the same line here, or sorry, x equals negative 3. So that's this guy. Equals, there we go. Oh, that's so annoying. Anyway, whatever, x equals negative 3. So, shape's going to look like that. The difference between the last shape and this shape was the last one, I described it as like a donut with the top had been chopped off from the top of a donut. Well, this is kind of like the same thing, except for there's no actual hole in the middle, It's one of those donuts that, it's really, really tight on the inside, but they're like more like a cakey donut as opposed to like a, like a glazed donut, right? One of those ones that looks like this, and it's like just got a hole right here, and it's like, tasted good, right? But only the top half. So, let me draw in, undo. Let me draw in what it's going to look like. It's going to go like that. It's going to come around the back. And then there's going to be part up top like this that connects. Goes around the back like that. So, same thing. Hold your pencil. Do we hold it up and down, or do we hold it horizontally to kind of indicate where the center of this thing is? Well, you should be holding it up and down. And when I'm doing dx is there, because I want to stick with dx. You could totally do this in dy. But since I'm doing dx's here, I hold it straight up and down. That means I'm using washers. So, get rid of that top piece so we have a little bit more space to work with here. So, I am gonna take I need to figure out the radius and the height. So I'm gonna stick in the positive quadrant there. And remember, here's what my shells are gonna look like. Now this is gonna be here and here. It's gonna swing out front. So this is like one cylinder shell slicey thing. Boom, like that. So you need to just add all those up over that dx, right? So now you got to figure out what the different how the radius plays a role and the height plays a role in this thing. So the radius is going to be this length. Maybe I'll go like this. This length right here. So and that's from the green central revolution line out to the X spot, right? So notice I've got this. I'm going to break it up into two separate blocks. This piece and that piece. So the first piece there, well, that's the width of half of the parabola. So that is 3. And then that next piece is the x-coordinate for the parabola there. So my radius is going to become 3. I'm going to add those two blocks plus x. You may be like, well, wait, what's going to happen when we're over here if I have like the smaller cylinder that would have this and be connected there and there? Well, when x becomes negative, then I'm going to do 3 minus a number, which is going to take me to here, right? So it'll work out there too. So that's my radius. And then my height, my height's the same thing as the last one. It's the parabola. Height is top minus bottom. Oh, and I guess I should say real quick that I could have done right x minus left -3 and gotten this as well. But I think that it's easier when I have a mixture of positive and negatives to do this, but you may think differently. Anyway, so I do top minus bottom. The top is the parabola, which is 10 minus x squared, and the bottom is the y equals 1. So that gives me the same thing that I had last time, which is 9 minus x squared. So now I just fill it in. V equals 2 pi integral r is 3 plus x, and h is 9 minus x squared dx. Last thing to do is fill in my bounds. Well, since that cylinder, I get this side of it, and when I do this side of it, right, you should see that. Well, I got to do little cylinders all starting here, I go all the way up to here until I get to here, and I'm done. So I'm going dx's, so I start at x equals -3 and go to +3. So -3 to 3. There we go.